Okay, so today we'll look at random variables. That is topic 2. Now we have got two types of random variables. The first one, discrete random variables. The second, continuous random variable. When you say discrete, we mean countable. Continuous, non-countable, mostly intervals. Those are continuous. So we'll start with the discrete ones. Discrete random variables. By definition, by denotation, this guy is what we call a discrete random variable. That's how we present the function. Instead of saying f of x, we say px is equal to x. The px, bigger x, that's a variable. The x inside, that's an element. So the variable is, it keeps varying. So at a small x, that's the variance. So now this small x is the one equal x1, x2, x3, keeps going. Where these form this set. That's the bigger x. Okay. And it's sometimes called the probability mass function. Now there's an important theorem that helps us appreciate this. So if the function is a probability function, then we know that 1, this should be greater or equal to 0. Always positive for all values of x. So for all xi's. The second one, if you sum at all the xi's, you sum f of xi, which is the same as the sum all xi's, x is equal to xi. This guy should give us 1, meaning that probability will always run from 0 less or equal to the function less or equal to 1, always. Okay, so there are so many examples, but I'm not doing the small examples. I think I want to start with an example of this nature. So examples. Example 1. The probability distribution function for random variable x is given by, so mostly for discrete, we'll get them in this form. X, and then here I can use x is equal to x. Okay. That's and now list the x1, 2, 3, 4, 5, 6. Then 0.1, 0.1, 0.2, 0.15, 0.4, 0.15, 0.05. Question A, find the CDF of X and sketch it. So the theorems on the CDF so you'll be seeing them as we do examples. So I'll be trying to explain each of the important theorems in the CDF. So how do you come up with the CDF of a function, of a probability function that is discrete? What do you do? So what you do is you start from the first one. So you start from the probability X is less or equal to 1. Meaning, in this case, we are dealing with X equal to 1. So get 0.1. The second one, X less or equal to 2. Meaning, you have the probability that X is equal to 1 plus the probability that X is equal to 2. That is going to be 0.1 plus 0.1, which is 0.2. The probability that X is less or equal to 3. This is the probability that X is less or equal to 2 plus the probability that X is equal to 3. So what I mean by less or equal to 2, I'm avoiding to add probability 1, probability 2, probability 3. So since I've already added this one, I'm just saying 0.2 plus 0.2 for X3, so that we get 0.4. Then the probability that X is less or equal to 4, it's the same as the probability X is less or equal to 3 plus the probability X is equal to 4. This will be 0.4 plus 0.4, which is 0.8. Then the probability X is less or equal to 5. This is the probability X is less or equal to 4 plus the probability X is equal to 5, which is 0.8 plus 0.15. This one will give us 0.95. The probability X is less or equal to 6. This will be the probability X is less or equal to 5 plus the probability X is equal to 6. That is 0.95 plus 0.05. That is 1. So always, if it's a true probability, then you must get 1. And that's how we obtain. So now we can put this together to give us the required CDF. For discrete, you notice that that's how the function comes out. This is for 0 less than 1. Then for 0.1, as you can see up there, this is for X. Now this is for 1 less or equal to X, which is less than 2. And then 0.2, this was for 2 less than X, less or equal to X less than 3. And then 0.4, this was for 3 less or equal to X less than 4. And then for 0.8, this was 4 less or equal to X less than 5. Then 0.95, this was 5 less or equal to X less than 6. And then 1 for X greater or equal to 6. That's how you present your CDF function. Then they say sketch. So how do you sketch the CDF function? So our sketch runs from different colors. So 0.2, 0.4, 0.6, 0.8, 1. And then down, we have 1, 2, 3, 4, 5, 6. So to start at 0, So at 0, there's nothing. So at 1, so 0 to 1, you can see that anything less than 1, you have said it's 0. So you open there and you go this side. So it's 0, you go in the other side. And then from 1, you close all the way up to 2. It's giving us 0.1. So I need to be very close to 0. So since my intervals are 0. Let me use a sharp one. So this one in between here, all the way up to 0.2. Then it will go to 0.2 now. 0.2 now. Very closer there. All the way up to 0.2. All the way up to 3. Then at 3, from 3 to 4, it's 0.4. So at least now we got space 0.4. Start from there all the way up to there. At 5, 0.8. So at 5, 0.8 closed all the way up to 6. It's open. I mean at 4. So at 4, 0.8. From there closed all the way up to 5. Then at 5, 0.9. Closed up to 0.6. Then at 6, closed at 1, going this side. So always be 1 going the other side. So that my scale there is not that okay because of the space, I think. That's why I could not illustrate on a bigger shape. So then, after you get the CDF and you get that, the follow-up question is B, find the probability that X is greater or equal to 4. So this is the same as the probability that X is equal to 1 minus the probability that X is equal to that X is equal to, that X is less or equal to 3. It's the same thing. Or simply do the addition. Okay, that's done. That then confused. X is equal to 4 plus the probability X is equal to 5 plus the probability X is equal to 6 plus any other, nothing. That's the maximum. So we end there and then get what's the probability X is equal to 4. So we got X is equal to 4. So that probability to get from the PDF, not the CDF, just that from the PDF. 4 is 0.4 plus 5 is 0.15 plus 6 is 0.05. Altogether we get 0.55 plus 0.05. This is 0.60. Like that. Or simply, this same probability here would also work if you understood that you get the total probability, which is 1, and then subtract the probability that X is less or equal to 3, which is 1 minus probability X is less or equal to 3. We got it in the CDF. In the CDF, less or equal to 3, we got 0.4. So you subtract 1 minus 0.4, so you get 0.6. The same as that one. Then C, the probability that 2 is less than X, which is less or equal to 4. This is the probability that X is equal to 3. For discrete, less or equal to is very, very important. If you stick to less, you don't include that number. So it's different from continuous. So you see the difference when you look at continuous. Then plus the probability that X is equal to 4. For 3, it's 0.2. plus for 4 is 0.4, giving us 0.6. Or you just got the CDF and subtract the fourth piece minus the second piece. Just to still get the same answer. So that's how you get the probabilities for discrete. Okay. For continuous, the second one, continuous probability function. Continuous random variables. For continuous, we say, of course, we still have the same property that f of x should be greater or equal to 0 for all. But second, you don't do the addition, we do the integral. If you integrate for all x, f of x dx, you must get 1. That's the difference now there. For discrete, we sum. For continuous, we don't sum, we integrate. Okay. And so when we say find the probability that x, that a is less than x, which is less than b. This will be the same as saying find the probability that a is less or equal to x, which is less than b. It will be the same as saying the probability that a is less or equal to x, less or equal to b, which will be the same as saying the probability of a less than x, less or equal to b. Same. It's different from discrete. For discrete, if it's less, it means something different from less or equal. For continuous, they mean the same, because you're integrating. And then the only thing that is important here is knowing how to get the CDF. If you observed here for the discrete, we're adding the CDFs of the previous to the next. So to add, if I'm getting for less or equal to 1, there are no addition. For 2, I would go back and add 1 plus 2. For 3, I would go back and add 1 plus 2 plus 3. For 4, 1 plus 2 plus 3 plus 4 probabilities. So we do the same even for continuous. When getting the CDF, though here you're going to integrate. So to get this guy, you're going to be integrating from negative infinity to x, and then you will change your variable for the sake of easy integration. So that if you are given the CDF and they ask you to provide the PDF, you say, then the PDF from the CDF will just be the derivative of the integral. Remember, your integral looks like the variable t, but at the end of it, when you're done, it will be a variable of x. Then you differentiate with respect to x to get back your PDF. So I do an example also here. Example, a continuous random variable has PDF f of x is equal to kx squared -1 less than x less than 2. Find A, the value of k. B, the CDF of x. And C, the probability at 0 is less or equal to x, less or equal to 1. So we start. The value of k, we said If you integrate all x, f of x dx, we expect to get 1. So for a, we'll integrate from -1 to 2 kx squared dx and equate it to 1. This will be kx3 over 3 from -1 to 1 must give us 2. That is, we substitute 2, we'll get 8k over 3 minus, we substitute 3, you get negative k over 3 if we substitute -1 to the power 3. So that we get 8k plus k over 3, which is 9k over 3, which is equal to 3k. Now remember, everything is equal to 1. This implies that k is 1 over 3. Now after you get k, you now know that our function is 1 over 3x squared. This is our function. Okay, so if this one is our function, now we must find the CDF. So the CDF, the CDF will run from, so I'm saying f of x is going to be, you get it in pieces. The first one will be you integrate but for this one, which is not piecewise, it's just an easy thing, like how you get it. The first thing that you do is you first say 0 for x less than or equal to -1. Since -1 is not included in our interval there, there's no harm. Then second, you integrate 1 over 3 x squared dx. Okay, from negative. Now, do you say negative infinite? No, because we have -1. So from -1 to where? To x. Then I'll come back now and change the variable. So I'll say t squared dt. So that it will be 1 also for x greater or equal to 2. So for the middle part, this one is -1 less than x less than 2, the most critical part. So it's still 0 for x less or equal to -1. And then here integrate. So when you integrate here, you get t3 over 9. Then substitute -1 and x. So it will be x3 over 9 plus 1 over 9. When you do the integral there, for -1 less than x less than 2. And then it will be 1 for x greater or equal to 2. That's how you always get there, the CDF of that function. If they ask you to sketch, of course you are sketching a piecewise function. So if they say the sketch, so you'd say from negative, say from -1, it's 0, including -1. It means 0. And then it will change all the way up to 2. It will be x3 over 9. So when x is 0, you get 1 over 9. But it's not a straight line, something like that. And then when you reach at 2, we're saying it will be fixed to be 1. So that is 1 there. So it remains 1 forever because don't go beyond 1. If I can draw it properly, that's straight line there. Something like that. Okay. So then, what about the C, where you get the probability from 0 to 1 of the very function? So we get for 1 over 3 t squared dt. which is the same as substituting f of 1 minus f of 0. Since the integral is known here, you just use this substitution. You take 1 there, you get 1 over 9 plus 1 over 9 minus 0 over 9 minus 1 over 9. So we just remain with 1 over 9, because the other part will be taken out. So that's how we do the PDF function. Okay, so nice. So I'm going to be doing this. Even if you miss class, I'm going to be doing this. Even if I'm alone, I'm going to, for that step for class, I'm going to be starting the class. You join if you're able to join. If you're unable to join, I'll keep the video and upload in the group. Also, the video goes straight to the YouTube. So if you're subscribed already, it becomes easy because once I post, it will notify you, and then you just get to watch the video. So I'll be doing this for every class. So this was the first class on probability on random variables. The next class, we'll do some more examples of random variables, how to move from CDF to PDF, and then from there, we'll start looking at the special expected values, meaning the mean, the variance, the standard deviation, and then look at the homogeneity function. And then we'll start now looking at all the theorems there and the proofs, so that need to be proved. And then we'll start now getting the special continuous random variables, those that are named and also for discrete. So we'll move a bit fast now. I hope you keep track. Thank you.